In the last section, I mentioned that components need to be able to listen to events that get fired. In this section, we'll take a closer look at how we implement that functionality. When the user interacts with a component, like when the user clicks a button or presses enter while in a text box, the component fires an event. If the component has a listener attached to it, the fired event is heard by the listener and consequently handled by the listener. The listener handles the event by executing the code in its action performed method. Let's take a look at how to implement a listener for a text box. First, we must define a class with an implements action listener clause. That means the class is an implementation of the action listener interface. So you see that right here. Next, we include an action performed event handler method in your listener's class. Note that if the action event handler parameter, in this case E, is not used, you still need to define it. So why do you think that is? Well, because when a text box enter event occurs, the JVM looks for an action performed method with an action event parameter. If the JVM can't find that exact method signature, then no event handling takes place. So in other words, the JVM is looking for exactly an action performed method that takes one parameter, an action event class, and will call that method when the event happens. If this part isn't here, if this part right here is missing, it's not going to call it when the event is triggered. Next, we must register the text box listener object. For example, in the greeting program, the create contents method registers a listener for the name box text box like this. In this example, name box right here is our text area component. And listener is the class that we just created that implements the action listener interface. Event handling requires the use of the action listener interface and the action event class. Those entities are in the java.awt.event package. So that package must be imported for the event handling to work. Note that you have to include the whole package name right there. Okay, you can't just do java.awt. That is a different package. Okay, so you've got to use the whole thing. In our discussion about component listeners, I mentioned that our listener class must implement the action listener interface. What may not be clear to you is what an interface actually is. So let's take a look at that. An interface is a class-like entity whose methods are all empty. If a programmer uses an interface to implement a new class, the compiler requires the new class to implement methods for all of the interface's methods. So what's the point of having a class-like entity with all empty methods? And more specifically, what's the point of the action listener interface? Well, we can use the interface as a template or pattern when creating a class that falls into a certain category. So in the case of our example, since all the component listeners must implement it, it means that all component listeners will implement the action perform method with the proper heading. And that ensures that the component events will be received properly. So here you can see the Java API for the action listener interface. You can see that it extends the event listener class. So we know that it's a child of the event listener class. But this is it. That's all there is to it. There's one method called action performed, and it has a parameter of an action event, and it returns a void. That's it. So to implement the action listener interface, your class only has to support this action performed method right here. If it doesn't, you'll get a compiler error. So that's it. This is a very simple and straightforward interface. Before we look at our full example, we have one more concept to visit, and that's inner classes. If a class is limited in its scope such that it is only needed by one other class, then define the class as an inner class, i.e. a class that is inside of another class. Since a listener is usually limited to listening to just one class, listeners are often implemented as inner classes. And to further the goal of encapsulation, hide the inner class by declaring it with a private access modifier. Besides furthering the goal of encapsulation, what's another reason to use an inner class as opposed to a top-level class? And by the way, a top-level class is the formal term for a regular class. So this right here would be a top level, and this down here would be an inner class, right? Because class B is inside of class A. Well, an inner class can directly access its enclosing class's instance variables, and listeners normally need to access those instance variables to do whatever work that they're going to do. So this is an important added benefit.
Okay, so now that we've gone through action listeners and interfaces and inner classes, let's take a look back at our program and go through those things so you can see what's happening. So here is the major block of stuff that we want to talk about, right? We have our private class listener that implements the action listener. Notice that the definition of this class is inside of the greeting class. Okay? This is what makes it an inner class, the fact that it is inside of the inner class, or the outer class. Also notice that it's private, right? This means that it will not be exposed to things that are outside of this program, or outside of the greeting class. Notice that it implements action listener. And we already took a look at that, and to implement action listener, it must have this action performed method that has this action event parameter. If it doesn't, it will get a compiler error. So let's take a look at that. If we compile this, we can see that it compiles successfully. Now watch what happens when I remove this parameter. Even though we're not using it, let me compile it, and right there, error. Greeting listener is not abstract and does not override abstract method action performed event in action listener. Okay, so right there tells us that we did something wrong. So if we put it back, right, action event E, and compile it, compiler's happy again. Okay, so you have to have a perfectly matching method heading for the class that is implementing the action listener class. And the rest of it is the same, right? So we've covered inner classes, and we've covered the implementation of the interface. And so if we run the program, we get what we get always. And if I can drag it over here, it's kind of small. You can see it. Hey, glad to meet you, Corey, right? So that's that. It's the same program as we looked at before, but this time you can see, you can have a better understanding of what's going on in this section right here.
Now, we've worked with anonymous objects before, but we can do something similar with classes as well. So let's take a look at that. The point of using an anonymous object is to avoid cluttering up the code with a variable name when an object only needs to be used one time. And we can do the same thing with an anonymous inner class, where we only use the class one time, so we don't need to actually instantiate it and do a reference variable and all this. Well, we need to instantiate it, but we don't need to store it in a reference variable. So here's the syntax. You have the keyword new followed by the interface name. So the inner class must implement this interface name that we're going to pass in here, right? And here's an example of it. Here we're adding an action listener, and here we are saying, you know what, we're having a new action listener, right, which is an interface. It's not a class, but the body down here is actually the class that's going to implement the action listener, right? Remember, this is an interface. So as an interface, our code must meet the requirements of that interface, which is, in this case, we have to have an action performed method that takes an action event parameter. So you can see here our inner class does that, and so we don't actually have to construct a whole class. We can use an anonymous inner class.
So let's take a look at how we can change our greeting program to support the anonymous inner class instead of using its previous implementation. Here's the previous version where we actually create an inner class, and then up here we instantiate a new listener, right? Now this is an anonymous class in and of itself because we are not instantiating a actual reference variable, right? We could do that. We could say action, whoops, helps if I can type, action listener, we'll say, we'll just call it Bob. That's not very self-documenting, right? So let's do, we'll just call it action listener, lowercase, right? Equals new listener, right? And then we can pass in this action listener object for our code here, right? And that's going to compile successfully. So this is a non-anonymous class, right? Or we can shortchange that and say, you know what? We don't actually need to store it in a variable. We can just put that here, right? So that's going to create a listener object and pass it into this add action listener method. All right, so that's an anonymous class, but that's not an anonymous inner class. What we can do with that is, if we look at this version of it, you can see here where we have our add action listener. Okay, compare that to over here. There's our add action listener. If we go back to our anonymous version, you can see here we are passing in this anonymous class to the add action listener method, right? So that's the difference between the two things, is we don't even have to set up a private inner class. This is going to be private automatically because it's already inside of this action listener method. So if we can compile it and run it, and you'll see that it runs just fine, right? What's your name? Bob. All right, so that's an anonymous inner class. It's anonymous because we don't have a name, and it's anonymous, or it's an inner class because it's inside of the class that we're calling. In this case, it's an inner class to the method because it's not even visible to the class. There you have it.
So now that we've covered some of the more complicated concepts for GUI programming, let's take a step back and look at some more components that we can use in our GUI programs. A JButton component is exactly what it sounds like. It's a button that you can click to trigger an event. And creating one is very simple. We just use the JButton constructor like this, and then we add a button to our window by calling the add method, passing in the button as an argument. In order to use the JButton, we must make sure that it's imported with the JavaX swing package. And you can see that right here. Okay, so that's different from our action listener where it was the Java AWT.event. We need to make sure that we are using the JavaX swing package to use a button. Of course, what good is a button that doesn't do anything when you click on it? So with that being said, we must implement a listener class that will handle the click event. And then register the listener with our button. Once this is done and we run our program, anything we specify in our action perform method in our listener class will be executed when we click the button. So whatever we define right here is going to be what happens when we click. In addition to the add action listener method, the JButton class has several other useful methods. We can get the label text, or we can set the label text, and of course we can also show or hide the button. Let's examine an example program that puts what we've learned to use. In case you've forgotten what a factorial is, it is the product of all positive integers less than or equal to it. For example, 5 factorial equals 5 times 4 times 3 times 2 times 1, which equals 120.
So here's our factorial button class, okay? And you can see we're importing the three things that we say we usually need to import. We've got our Java X Swing, we got our Java Abstract Windowing Toolkit, and then our Abstract Windowing Toolkit event class, right? And so here we just set up our static final height and width parameters. So we could change these, which is nice because then anywhere we need it, it's in the program, it's been updated, right? So we don't have to mess with anything down here. And here's our constructor, which we've already seen before, where it initializes everything and then sets the visibility to true as the last step. Here's where we create our contents. So we are just creating a couple labels called x and x factorial, and then we're creating a button with the label of factorial, and then we create a listener reference variable. And this is where we additionally add a text box, right? And then we add all the different components that we've created up here to our actual frame, JFrame. And then we add our listeners to those objects that need to listen, right? So what this is basically doing, notice how they're adding the same listener. So whether we hit enter in the text box or click the button, it's going to do the same thing. So here you can see that we have two ints called x and xif. And here, notice that we're using our try catch blocks because we're going to try to parse it as an int. But it may not happen, right? If it does, it's going to set x equal to -1, right? Which is an invalid x. Okay? And then so if x is less than 0, then it's going to set the thing undefined. So no matter what we put in the text box, if it fails, it's going to set it to -1, right? If it fails to convert it to an integer, it's going to set it as -1, which is going to print out undefined. So that is a little bit of code to make it more robust. Then finally, if x is equal to 0 or 1, it's going to return the factorial as 1 because that's the mathematical definition. Otherwise, we're going to just loop through our count, and we're just going to do 5 times 4 times 3 times 2. Well, actually, we're starting up from 2 up until it's equal to the value. So if we put in 5, it's going to start at 2 and do 2 times 3 times 4 times 5, right? And then it sets the text to whatever our final value is in the output. And that's the entire program. So let's compile it and take a look at it. So I'm going to launch and factorial button. And here you can see it's a little bit bigger because I changed the height and width size, right? So if we put in 6 and do factorial, you can see it produces 720. If I put in -6, look at that, undefined. Notice that time I just clicked enter in the text box instead of clicking on factorial. I could type in NM and hit enter, and notice that it says undefined. I put in 10. Factorial. Hey, look at that, right? So that's the program, and that's how it works.